Okay, good afternoon, everybody. Pulpin Watana, Vanessa, and I cannot see other names, maybe on the other page. Guys, I hope you're all doing well. We are in the second week of this online learning, and I hope we will get back to camp soon, hopefully. Okay, so we will continue learning about differentiation, and in this class, we will talk about implicit differentiation, and on Wednesday, I'll talk about related rates. And Thursday, linearization and differentials. And Friday, I will see. Okay. So if you want to discuss something, we will have class maybe on Friday for discussion. Otherwise, I'm going to give you some time for preparing for your midterm exam. Next week, Wednesday, you will have midterm exam from chapter 1, 2, 3, 4. Okay.
Professor, what about the quiz?
There is no quiz. Okay, you will have quiz after chapter 4. From chapter 4, now you'll have midterm exam. Okay, so just prepare for your midterm exam. Questions are from chapter 1 to 3, especially most questions come from chapter 3. So, guys, now we will talk about implicit differentiation. Okay, usually the functions are expressed implicitly or explicitly. Okay, and so far we have been dealing functions which are expressed explicitly. When we just say explicitly or implicitly, what we mean? Like, for example, if you look at these examples, x cubed plus y cubed minus 9xy, right? Actually, if you try to express this y in terms of x like this, y is equal to f of x, right? And we just try to express this function explicit way. So actually, the function, I mean the expression on the right hand side in terms of x, it may be very complicated, and complicated by what I say complicated in the sense that it is not so easy to differentiate this. Maybe in the future also it's not easy to integrate this. Okay, we better keep the function in this form. So if the functions are in this form, what is it? As you see here, the function is here. It is just in this form. Here we have capital and the x and y is equal to 0. And here we assume that x is independent variable, y is dependent variable. And after all, it depends on your choice. You can take y as an independent variable, x as dependent the variable is sub key. After all, doesn't change anything. Okay. And another also example is y squared is y squared minus x, right? And also here the function is defined implicitly or implicit way. What is it? Here we have f of x and y. On the right hand side we have 0. What is our f of x? Y? It is y squared minus x. And also third example, x squared plus y squared minus 25 is equal to 0, right? And also here that is given, right, that f of xy is equal to 0. And actually you are familiar with this equation, right? What is it? It is just equation of a circle. And how about the second example? It is the equation of parabola. Okay. So now here, what are we going to study here? We are going to just study how then, if the function is defined implicitly, how do we differentiate this? Okay. And after that, if you can differentiate this, how do you find its slope? And after that, how can you write the equation of a tangent line? Okay. That is what we are going to learn here. Okay. Now, if you look at this example, find dy dx. That means that the derivative of y with respect to x, which is actually given by this equation, right? X squared times y plus x times y squared. Actually, in advanced calculus, it's given that if the function is defined implicitly, actually every function can be expressed actually in explicit way. I mean, we can just convert this or transform this into another form where on the left hand side we have only independent variable, on the right hand side we have on the right hand side we have independent variable or variables, on the right hand side we have only dependent variable. And just assuming that here, for example, this equation, I can assume that x is an independent variable and y is dependent variable. And also I assume that y is differentiable function of x. Okay. So just keeping this in mind, that I'll just continue here. How do we differentiate this? To do this one, I'm just going to do the same operation using quite a simple thing. We know that in math, if you're given an equation, if you do the same operation to both sides of the equation, it does not change the solution or what is it, characteristic of the equation. So let me just differentiate both sides with respect to x. So left hand side, here we have x squared. Let me just write x squared as x squared y plus x y squared. On the right hand side, we have the derivative of constant function, right? So now you can just suppose that here we have the product of two functions. It's like u times v. And also here we have product of two functions. And we are just differentiating this with respect to x, right? How do you differentiate this? If you differentiate the first one, for example, dx, here we have x squared times y, right? First, I need to differentiate this, the first part, u with respect to x. What is the derivative of x squared with respect to x? That's equal to 2x and just y here, right? And the second part, dx, here we have xy squared. Sorry, I should actually continue here. It's a product of two functions, 2x times y plus x squared. Now derivative of y with respect to x. And how y is expressed in terms of x, we don't know. I just keep it as dy dx, right? In a similar way, how about the second term of the function dx here? We have x y squared, right? If you differentiate x, the first function, that is just 1 times y squared, plus here we have x. Now, how do you differentiate y squared? It's like a composite function, right? First, we need to differentiate this with respect to y, which is equal to 2 times y, times, and after that, we need to differentiate y with respect to x, which is dy dx. So now if I substitute there, on the left hand side, I just have the sum of these two things, right? So here I have 2xy plus x squared times, just for simplicity, let me just keep it as y prime. And the second part is y squared plus 2xy times y prime, which is equal to, on the right hand side, the derivative of 6 with respect to x, that's equal to 0. Okay, so now as you see here, we have an equation. And what is unknown here? I'm looking for dy dx, right? Here, dy dx. So just simple, I need to solve this equation for y prime. And it's just a kind of linear equation. Take everything to the right-hand side, and y prime is a common factor. Here, y prime, and here we have x squared plus 2xy equals, on the right-hand side, minus 2xy minus y squared. Now, if I divide both sides by x squared plus 2xy, here we get here y prime, which is dy dx. That's equal to minus 2xy minus y squared over x squared plus 2xy. Okay. Actually, the idea is that simple, all right. And simply what you have to do here is just in always throughout this process, you need to keep in mind that y is a function of x, okay? It's just not, y is not an independent variable. Another example, find the slope of the circle x squared plus y squared equals 100 at the point 68, right? And how do you find the slope of the, what is this circle at this point? What happened? At this point, this m, right? We know that this m is equal to dy dx at point P, right? That is actually the slope of this line here, but here the point is, let's say it is P, where it is 6 and 8. So again, using the previous idea, I'm going to differentiate both sides with respect to x. If you differentiate 2x x squared with respect to x, that's equal to 2x. And how about if you differentiate y squared with respect to x, that's equal to 2y times dy dx. On the right hand side, it's just a constant function. If you differentiate it with respect to x, that's equal to 0. Okay. Now, if from here, if you just solve for dy dx, assume that is equal to y prime using just y prime notation, that's equal to take 2x to the right hand side minus 2x over 2y, which is equal to minus x over y. Now, what is the value of this derivative of this function at p, right? So that's equal to minus at p, x coordinate is 6, y coordinate is 8, which is equal to minus 3 over 4. Now, if we need to write the equation of the tangent, tissue. Tangent, what is it? It's just y minus y sub 0 equals y prime of x sub 0 and x minus x sub 0, right? So from here, y minus, what is y sub 0? It is 8. Y prime x sub 0, that is minus 3 over 4. X minus x sub 0 is 8. The box of tissue. Yeah. Do you have one? We have a lot of boxes. Bring one. Okay. Well, let's continue. So now let's just summarize what we have done in the previous two slides. So implicit differentiation, what do we mean by this? So differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. Otherwise, we cannot differentiate this. Doesn't make sense, right? And collect the terms with dy, dx on one side of the equation and solve dy for dy, dx. That's what we have done. Actually, in general, this is a method, actually, how we differentiate implicitly defined functions. Another example, dy dx, if you actually is given by this, okay? So that means that our f function is y squared minus x squared minus sine of xy is equal to 0. Again, to do this one, if you differentiate both sides with respect to x, what do we have here? On the left-hand side, we have these y squared, that is 2y, and here we have dy dx plus equals, on the right hand side, x squared, that's equal to 2x plus, and how do you differentiate like sine of function g, right? First, we have to differentiate with respect to sine, that's cosine, and also we have to differentiate inside with respect to x, right? So that means that here, if you differentiate sine function, so here we have cosine of x times y, and after that, we need to differentiate inside, right, with respect to x. That is x and y, which is equal to dx plus, and here we have cosine of x times xy. And how about if you differentiate this xy? With respect to x, that's equal to y plus x times with respect to y, that is dy dx. Okay, that is, you should be a bit careful here. So now I need to solve for dy dx. Again, dy dx, suppose that is just our x. Okay, not x. If I say x, you'll get confused. Let's say it is y prime, okay? And also this one is y prime. So what do we have here then? Here we have d2y times y prime, and that's equal to 2x plus y times this, that's equal to y times cosine of xy plus an x times cosine of xy times y prime. So this term has y prime, right? And just we need to solve this for y prime. Takes to the left-hand side, and the y prime is a common factor. So here we have 2y minus x times cosine of xy. On the right-hand side, we have here 2x plus y times cosine of xy. Now from here, we need to find y prime. What is y prime? Again, it is just dy dx. That's equal to, in the numerator, 2x plus y times cosine of xy over, that is 2y minus x times cosine of xy. So as you see in the picture, that's the graph of this function. Okay, now if you try to express y, for example, in terms of x, and if you try to differentiate this, it will be very, very complicated. But some functions That's why actually in their implicit form, actually that is much easier to handle with these functions, or just to handle these functions. Anyway, let's continue. Derivatives of higher order. Okay, now not only one time. How about if you are asked, for example, to differentiate this kind of implicit defined functions twice? So actually the technique is the same, just we have to apply the same technique twice. Now suppose that we are given this equation. Okay, I assume that y is a differentiable function of x. As you see here in the picture, it is the graph of this equation. Okay, so at the time, how do you differentiate this? Again, first I should differentiate both sides with respect to x. If you differentiate x to the power of 2 over 3 with respect to x, here we have 2 over 3 times x to the power of 2 over 3 minus 1. That's equal to minus 1 over 3. Plus, how about this? Actually, with respect to y first, so 2 over 3 comes to the front, times y to the power of 2 over 3 minus 1. That's equal to minus 1 over 3. Times, now because y is a function of x, so differentiate y with respect to x. That's equal to y prime. On the right hand side, we have 0, right? Now from here, what is y prime? Y prime is equal to minus 2 over 3 x to the power of minus 1 over 3 over 2 over 3 y to the power of 1 over 3, which is equal to this 2 over 3, 2 over 3, they cancel each other, minus here we have, and minus 1 over 3, minus 1 over 3 is a common exponent or power. That's equal to x over y to the power of minus 1 over 3, or just that's equal to minus y over x to the power of 1 over 3. Okay. I have just changed upside down. As you know, a over b to the power of negative n. That's equal to b over a to the power of n, right? We will continue. That's our first step. But here we are asked to find the second order derivative of this function, right? Derivative of y with respect to x. So now I need to differentiate one more time. So now again, if you differentiate the left-hand side, it's y prime. So here we have y double prime. On the right-hand side, what we have here? Here, I think I better keep this in this form here, minus y to the power of 1 over 3 times x to the power of minus 1 over 3. So we have to differentiate the whole thing with respect to x. Okay, so equals, now this my negative, okay? So again, we have just the product of two functions. First, let me just start with x, okay? If we differentiate x, what we have here? Minus 1 over 3 times x to the power of minus 1 over 3 minus 1, that is minus 4 over 3, times y to the power of 1 over 3, okay? Plus, now here we have x to the power of minus 1 over 3 times, now we have to differentiate this y part. So again, that's just composite function. 1 over 3 comes to the front, y to the power of minus 1 over 3 minus 1 minus 2 over 3 times y prime. Okay. So next thing is we will continue immediately here. What we do we have any common factor? Yes. Okay, this 1 over 3 is a common factor, right? And if you just take this out, here we have minus 1 over 3. Okay, or how about if I just take minus 1 over 3 out, so it will be plus, this will be plus. At the time here we have x to the power of minus 1 over 4 over 3 times y to the power of 1 over 3 minus 1 over 3 is out. So here we have minus x to the power of minus 1 over 3 times y to the power of minus 2 over 3 and y prime. What is y prime? Actually, in the previous step, right, we already calculated y prime. That is minus y to the power of 1 over 3 times x to the power of minus 1 over 3. Okay, so that's it. And now if you simplify this, what we have here equals 1 over 3. Here we have x to the power of minus 4 over 3 and y to the power of 1 over 3 minus minus. Here we have plus. Here we have x to the power of minus 1 over 3, x to the power of minus 1 over 3. That is x to the power of minus 2 over 3 times y minus 2 over 3, 1 over 3. That is y to the power of minus 1 over 3. Okay, maybe you can simplify this further. I can just say the common factor, that is y x to the power of 1 over 3 and y to the power of 1 over 3 is a common factor. Take this out. And I think the idea is quite clear now. You know, actually the math is the same. The main idea is we had to just differentiate both sides of the equation and treating y as a function of differentiable as a differential function of x, and that's it. The rest is just simple algebra. Okay, so the last slide, and I will finish the class. That much is enough for this session, I mean for this part. Show that the point 2 4 lies on the curve, then find the tangent and normal to the curve there. Okay, so we have 3 steps here. Number one, we have to show that that point belongs to this curve. How? I have to show that when I substitute these points into the equation, it must satisfy, right? That means the left-hand side should be equal to the right-hand side. So if you substitute to the equation, here we have 2 cubed plus y is 4 cubed minus 9 times x is 2, um, y is 4, which is equal to 8. 8 plus 64, it is 72. 72 is equal to 0. So which is equal to 0. So it is true. That means that the point belongs to this curve. And number two, right, tangent. Tangent and normal to the curve there. There means at that point, right, at 2, 4. Okay. So to find the tangent again, we need to find first the slope of the tangent, right? So if you differentiate again both sides with respect to x, here we have 3x squared plus 3y squared times y prime minus 9. And if you differentiate x with respect to x, that's equal to y. So here we have y plus here we have x times y prime. That is equal to 0. Now from here, what is y prime? Okay, here we have 3y squared times y prime. Here we have minus 9 times x. So here we have minus 9 x y prime. And take everything to the right hand side. Here we have 9y minus 3x squared. So now y prime is a common factor. Take this out and divide both sides by, what is it? 3y squared minus 9x. Okay. So now from here, what is y prime at point P? And suppose that the point is P. Okay. So that is x coordinate is 2, y coordinate is 4. That is 9 times 4 minus 3 times 2 squared over 3 times 4 squared minus 9 times 2, which is equal to 36. 4 is 12. 36 minus 12, that's equal to 24 over, that is 48 minus 18, that's equal to 30. By 6, it is 4, and it is 5. So that is the slope of the tangent, right? If the slope of the tangent, and how do you write the equation of the slope? That is y minus y sub 0, that is 4, equals m is 4 over 5 times x minus x sub 0. X sub 0 is 2. And how about the normal? And as you know, actually, if two lines are, what is it, perpendicular to each other, the product of their, what is it? The product of their gradients, m1 times m2, should be equal to -1. From here, the equation of the normal will be y minus 4. Its slope is minus 5 over 4, and it passes through the same point, x minus 2. So these are the equations of tangent and normal. Okay, guys, thank you very much. That's enough for today. It's all about implicit differentiation. Okay, on Wednesday, we will study a very important topic, that is the rate of change. What is it? Rate problem simply. Okay, so Most questions also come from that rate problems in the midterm. Okay. Thank you very much. If you have any questions, please drop me in the Telegram group. We can also may have some discussion on Wednesday. Okay. I'll see you on Wednesday. Have a good night. See you. Bye bye.
Thank you. Bye.
Thank you. Bye bye.
Bye.
Bye
Hi,
bye.
sir.
Bye. Thank you.